Welcome to the demo video showcasing Edge AI on VMware Edge Compute Stack. We're going to demonstrate how easy it is to deploy an Edge AI inferencing application on VMware Edge Compute Stack. VMware Edge Compute Stack supports the use of GPUs and makes it easy to consume for the VM and container applications. In this setup, we are running a server with NVIDIA A2 GPU. We install the VMware Edge Compute Stack runtime on the physical host, which provides the ability to run virtual machines as well as container workloads. We make use of an AI model based on the YOLO algorithm for object detection. We tweak the model using RoboFlow software to detect tanks and package it in the form of a container and store it in Docker Hub. We then create a Kubernetes manifest file for deploying the application and store it in Git. In addition, we also make use of the NVIDIA GPU operator for provisioning the GPU, as it helps automate the management of all NVIDIA software components needed to provision the GPU. Once we add our Git repository into VMware Edge Cloud Orchestrator, the configuration is pulled down to the host and our tank detection application with the GPU associated is provisioned and ready to use. Note that we have already installed VMware Edge Compute Stack on the host and added the host to VMware Edge Cloud Orchestrator for this demo. If you would like to know more about the process, please take a look at our other video on the VMware SASE and Edge channel on YouTube. We start by taking a look at our Git repository. We have a file for the NVIDIA GPU operator that deploys the GPU operator Helm chart. We also have our computer vision application YAML file, which requests for one GPU resource. We then navigate to VMware Edge Cloud Orchestrator and see that the Tactical Edge Git repository has been added. We have created a site called East Coast where the Edge host is deployed. We have also registered the host and associated the Git repository. Now we activate the host. Once the host is active, we take a look at the monitoring tab and give it some time to deploy the GPU operator and the computer vision application. We see that the GitOps status is now ready. Now let's take a look at what was deployed. We navigate to VMware Edge Compute Stack host UI and see that the NVIDIA A2 GPU is available under the PCI Devices tab. We then navigate to the EC Worker VM, which is where our application container is running, and see that the GPU is associated. All the settings required for making the GPU available to the AI application can be performed via the desired state methodology. To check if our application container got the GPU resource, we navigate to the diagnostics pod on ECS and see that the GPU operator and computer vision application has been deployed. We check the Kubernetes node and see that the GPU is passed through to the Kubernetes worker node. We then check the application details and see that the GPU is available to our application. We then access the EC Worker VM CLI and start watching the GPU usage to see if the GPU is used by the application or not. Initially, we see that there is no GPU usage. Now let's access the application. We navigate to our application and use some of the sample images available. We see that the AI model is running on ECS and making use of the GPU to process the image and provide the processed output image. We also provide a sample video feed. And can see the tank detection happening in real time. Thus, we saw how VMware Edge Compute Stack abstracts multiple layers of complexity in making the GPU available to the AI application, and we showcased how it can support GPU pass-through for multiple edge AI use cases.